Welcome to Thinking Deeply About Primary Education, the podcast that makes time and space to think about pedagogy, teaching and learning, professional development, anything of interest to time-poor but enthusiasm-rich primary teachers. This week, I'm joined by Emma Lindley-Thompson. Hi, Emma.
Hi, Kieran. Hi, everybody.
And John Jackson. Hi, John.
Hello again. Hi, everyone.
It's great to have you guys back. This is the third in our mini series, looking at your expert edit and some of the things that may have the almost the highest leverage for teachers from terms of their maths research base and what we do in the classroom. And we are going to focus on a paper from Bethany Rittle-Johnson and John Starr called Does Comparing Solution Methods Facilitate Conceptual and Procedural Knowledge? An experimental study on learning to solve equations. Again, John, you'll always go back to they love they love writing these nice, easily accessible titles. But essentially, we're looking at the comparison of solution methods. What's the premise of this paper, and how do they go about testing their hypothesis?
As you said, and actually the title it's not exciting, but it does tell you what's in the paper this time. That it's about whether it's useful to get pupils to compare different methods for solving problems. And yeah, so before kind of summarizing what that's about, like just to kind of go back to what we were thinking when we originally kind of wrote our expert edit, and that we were keen to highlight studies that did like three things in particular. Building on evidence from cognitive science, but in like a classroom setting, which was that kind of paper we talked about in the first conversation from Rohrer et al. About interleaving, like testing out well-established theories about maths teaching to provide experimental evidence, which was what we talked about last time with Fife et al.'s paper, and then finally like looking at things that maths teachers just do and like quite regularly in their classrooms, and then testing them experimentally to see actually is it a good idea. Or should we be doing other things? And that's what this kind of paper does. And I think there's kind of three really great things about this paper. Like it really defines what it's testing. Like the authors wanted to know whether comparing different solutions to problems helped pupils build procedural knowledge, so how to follow the steps in a process, conceptual knowledge, so that like understanding of concepts and connections and like why the process works. And then also flexibility with procedures. So can they adapt that process to a slightly different problem? And then they measured both like all of these before and then after the kind of experiment they did with the class using a pre and a post test. So that's what the first thing. Second thing is it manages to randomize the experiment. So some pupils in a class got prompted to compare solutions to kind of test if that works, and then others did not, which is great, gives you a kind of comparison. And they did that in the same classroom, which gives us some confidence that it might work for other teachers. By doing it in the classroom, that kind of gives us confidence that like it works beyond the lab. And then by randomizing within that same class, we can kind of eliminate things like, maybe just this class that did the comparing had the better teacher or something like that. And then kind of for those of you who listened to that first conversation about the interleaving paper, where they have the same teacher teach multiple classes, they did that in this one as well. And then the third thing was the design meant that they could hide from the pupils which pupils got the compare answers and which didn't. And then they listened to pupils' conversations to kind of check that had happened. And they did that in a really simple way, which is something I always like. So the way the kind of test worked is the kind of experiment worked is they got pupils to work in pairs, and half the class, so half the pairs, got a worksheet with two worked examples, which are side by side at the top of the page, and then both of those worked examples were for solving kind of fairly simple equations, and they used a different but correct method. And then below those two worked examples were some prompts that kind of encouraged a pair of students to contrast the two different solutions. I'll call the pupils who got that like the comparison group, and then the other half of the class got the same worked examples, but instead of being side by side, one was on the front of the page and the other was on the back, which made it quite hard for pupils to try and compare those when they were discussing. And the prompts were not about comparing; they were just about like explaining the solutions individually. So that kind of group, which I'll call a kind of sequential group from one after the other, they had to work quite hard to kind of go against the experiment and do some comparison themselves. And they kind of gave pupils a few different sheets like this, and then everyone got some individual practice to do, some like problems to solve, which were quite similar to the worked examples. And then a day later, everyone did a test. And the results from that were pretty clearly in favour of the comparison group. So that group did better on the post-test in terms of procedural knowledge. They were better at just like following the steps to solve equations, and also better at like flexibility. Like they were more likely to kind of take a shortcut or kind of apply it to a different sort of a slightly different problem they hadn't seen before. Interestingly, like both the kind of comparison and the sequential groups did about the same on conceptual knowledge. And the authors like speculated that might be because the prompts that they gave pupils were quite focused on the procedure rather than the kind of like broader concept behind them. So yeah, like I think really great paper, like nice and simple design in a classroom, gives us some like good evidence because it's randomized that yeah, like comparing different methods helps pupils in terms of procedural knowledge and like being more flexible, being able to apply that to different situations, and isn't any worse for like conceptual knowledge. There's probably a couple of limitations to be aware of. It's only routine like problems they're looking at, so they were solving like quite standard equations. So it's not really clear whether this applies to sort of like your kind of more one-off kind of worded problem that is quite a bit different to anything you've seen before. The setting was like quite particular, so it's a selective private school in the US, and like year 12 to 13-year-olds. So we don't like that's the setting it's in. Doesn't mean it doesn't apply to other settings, but it like is something to be aware of. The kind of age is significant, I think, particularly like talking on this podcast. It means they can read those worked examples themselves. They're not having to like have an adult decode them for them or anything like that. I'm sure that's something we'll kind of come back to later. And then in terms of forgetting, there was really little gap between the experiment and the test. It was just sort of one day. So we don't know about like long-term benefits of this. It could be that maybe it just made it better in the short term, and in the long term, that would be something it wasn't as good, and that would be something to follow up on. And then finally, there's quite a lot of classroom support. So they had like, I think Bethany, Rittle-Johnson, and two kind of assistants sort of circulating around as pupils are doing these problems, mainly to check that they were like following the experiment, but they were allowed to like help pupils with kind of calculations. So they couldn't, if the pupils were like, oh, I don't know what to do next in this equation, they couldn't answer that. But if they said, oh, I'm not sure, can you remind me how to divide by a quarter? They could answer that. So that's obviously not something that most classrooms have, like loads of like assistants going around. But overall, I think it's really useful and very, very kind of applicable to things that teachers do, sort of in the classrooms anyway.
I don't really know how I can follow that. Yeah, John, that was an amazing answer and super, super detailed. So yeah, I don't actually have, Kieran, anything really more to add, other than I thought it might be helpful for listeners to just remind ourselves of some of the kind of key terms that we might use during the conversation. I know, and John's kind of already touched on a few of those, which we do also write about in the expert edit if you've got a copy of that near you. But so there's three here that I'm going to just mention. So the procedural knowledge, which, as John mentioned, involves knowing the step-by-step process, methods or techniques required to carry out a particular activity. And in this context, this might mean the steps involved in solving an equation. So, for example, following the steps to solve 3x plus 5 equals 14, such as subtracting 5 from both sides and then dividing by 3 to find that x equals 3. And then we've got this like conceptual knowledge, which involves that deeper understanding of concepts, principles, and those overarching ideas within a particular area. So conceptual knowledge provides a framework for pupils to organise and make sense of information, providing pupils with a deeper and more meaningful kind of comprehension. And it's often also described as kind of conceptual understanding. So, for example, understanding why the steps in solving 3x plus 5 equals 14 work, such as recognising that subtracting and dividing maintain equality by performing inverse operations. And then we've got that concrete representation, so using those physical objects to introduce and explain new or abstract ideas. For example, using the Dean's blocks, or as some of us know them as base 10 blocks, to model that addition and subtraction by kind of like physically regrouping ones, tens, and hundreds, for example.
The point you raise about the vocabulary and the terminology is really, really important, because I see our 3 conversations as almost one extended conversation. Certainly the way you guys have structured the choice of paper and things, we mentioned that before. And so wherever playlisting is possible, like Spotify, YouTube, I'm very much going to be connecting these 3, because I think each feeds the other in a slightly different way. And, you could listen to 3 different orders and maybe develop your reason or your understanding in a slightly different way than if you went sequentially like we have and stuff, So I think, I think that's really, really important. The big question is, what are the key takeaways from the study?
It might be worth first thinking about kind of like the power of comparison as a learning process, which can be leveraged to improve learning in a variety of domains. And in a paper by Goldston, Day and Son, it's a 2010 paper, they said that comparison is one of the most integral components of human thought. And research has demonstrated that the simple act of kind of comparing 2 things can produce like really important changes in our knowledge. So I want to kind of like start with that. So when I was thinking about kind of like the key implications and the kind of like key takeaways from this study, I'm kind of drawn to that procedural knowledge. So as we said, the step-by-step methods and the conceptual understanding, that understanding of the principles behind the methods. And now in the expert edit, John and I refer to research by Ball 2001, Chazan and Ball 1999 that mention that the simple exposure to multiple ways may not maximize learning. So teachers need to consider carefully how comparing solution methods are implemented. And when I was thinking about this, there's kind of like 5 key things, kind of key implications that we can consider from this particular study. So one of them is explicitly teach and compare multiple methods. So the research highlights that pupils who compare different solution methods made greater gains in their procedural knowledge and flexibility than those who studied methods in isolation. So in our practice as teachers, we need to encourage pupils to explain those choices. So rather than telling pupils which methods to use, let them decide and justify why they choose a particular approach. And then the second one was kind of like developing procedural flexibility, which I know John's mentioned already, kind of by encouraging that strategy selection. So the research found that pupils exposed to comparisons were more likely to adopt efficient, non-standard methods, which are those shortcuts that John mentioned earlier. And provide pupils with problems that allow them to explore multiple strategies and then discuss when different methods might be useful. So for example, when multiplying, showing both like the grid method and short multiplication, and then have pupils identify which method is like quicker or easier for them. And then the third one was kind of supporting that conceptual understanding with discussions. So the research highlights that comparing methods alone did not enhance conceptual knowledge, and pupils benefited more when explicitly prompted to reflect on the underlying mathematical principles. So what this might look like in the classroom could be the use of those why questions to deepen thinking and encourage pupils to explain kind of why a method works and not just how to do it. And using kind of peer discussion, building on their reasoning. For example, when dividing fractions, instead of just teaching the kind of invert and multiply rule, ask pupils to explain kind of why kind of flipping the fraction works and using those like visual representations where you can. And then my fourth one kind of connects to something I mentioned in a previous episode about the use of concrete and kind of visual representations. And I spoke about the concrete, pictorial and abstract. And in this study, kind of learning was enhanced when pupils compared structured examples rather than just kind of hearing different methods described. And for me, I think this is really key. So before comparing kind of abstract methods, using those manipulatives, those Dean's blocks, those fraction strips, to really illustrate those key concepts. And then, as John mentioned, kind of teachers then could present those two methods side by side so pupils can directly compare those steps. And then the fifth one was kind of finding lessons that encourage that comparison. So simply showing multiple methods is not enough. The pupils will benefit most when they are actively engaged in comparing and contrasting. And that's where that use of paired talk comes in. So teachers could get pupils to first solve problems using different methods individually, and then compare with a partner before then sharing with the class, and using prompts such as what are the differences and similarities between these two methods? And when kind of solving problems, give those two worked examples and ask people which one they prefer and why. And then a final thought here is, rather than kind of teaching a single method or leaving pupils to just choose randomly, this study suggests that kind of structured comparison in really does improve that procedural fluency and flexibility.
Like your point about how fundamental comparison is really important. I mean, it's something that comes up like time and time again in research around learning, whether that's like looking at variation theory or like Engelmann's theory of instruction. And actually it kind of crosses like all sorts of different perspectives and things like that. And then that kind of final point around like planning your opportunities for comparison. I think that's really, really important too. I'm not going to add loads. I'm probably going to a couple of things I want to talk about, some of which will be kind of rephrasing what Emma said, I think, but perhaps useful just to have it in a different format. I think the first thing is that like definitely an implication for our practice is that getting pupils to compare solutions can be helpful. And it's something I'd encourage like teachers of secondary and like older primary pupils to do. Like my area of expertise is not younger pupils. I think we'll talk about that in a bit more detail later on. It's definitely worth noting that, as Emma said, the research didn't just give pupils two solutions and say, compare these. They taught them some maths, including how to do one of the procedures, and like enough kind of prior conceptual knowledge like that meant they could understand the other one, so they could see what was happening with the shortcut methods. And then they gave them really kind of careful prompts to scaffold their conversations. So like setting up that comparison is really important. And the second thing is maybe different to what Emma was talking about, like that there's an opportunity cost with all of this. If we choose to get pupils to compare correct solutions, like that might be a good use of time, but it's time we can't use for things like comparing correct and incorrect worked examples, or independent practice, or teachers' explanations, or open-ended problem solving. So like, I definitely encourage teachers to get pupils to compare solutions, but I'm certainly not suggesting that they should do that every single lesson. There's too much other good stuff that's useful for pupils and helps them learn. I'd pick places where flexibility is important. So maybe like solving problems with mixed numbers. Is it better to convert to improper fractions, or like partition into wholes and fractions? Like area and perimeter problems, I think you can often solve in a couple of different ways, and one way might be more efficient in some circumstances. And things like the real kind of classic example is like arithmetic, like things like whether shortcuts are like adding and subtracting 99 from things, like should you use the column method, or should you like add 100 and subtract 1, or what have you. So like summarize, I think we should get people to compare solutions, but probably only after they've had some teaching first. And even then they want structured prompts will help like everyone get the most out of that. And as always, do it judiciously, like not every lesson all the time. I think, and it's probably worth calling out that all of this relies on some pretty good routines, particularly around like paired conversations. But it's a kind of win-win in that like yes, it relies on that paired talk to make it work, but also these conversations will develop pupils' abilities to talk in pairs, which is great, like in terms of like language development, in terms of kind of justification of mathematical reasoning, all of these things, which kind of outcomes we want for pupils.
Where do we think responsibility lies for the methods selection and when they're introduced? Because I'm thinking in my head, in my previous school, it was embedded into our curriculum, and the teachers explicitly taught which mental methods were appropriate in which situations, or certainly what we'd identified, if that makes sense, because obviously there are many, many options. But in the absence of teaching children to calculate mentally, which was the old national strategy document outlining every single possible option you have, we would have it would be a careful route through maths that included this in it. And so in that primary setting, teacher expertise built as they used it. It may be different in secondary, where teachers are more aware of some of the connections between different solutions. I'm thinking with almost like quadratic equations and things, if you talk to 3 different maths teachers, they're going to give you 3 different preferences, that kind of thing. Should it be on the shoulders of the teacher, or is it probably closer to the maths lead / senior leaders to have this in place for their teachers?
I was thinking while you were talking there, I recall in one setting with a document, is a calculation policy, so it's attached to the full maths curriculum, and it's separated out all the different methods for each year group. So for the primary setting, and there was a lot of conversations around, well, if I'm teaching year 3, can I do things from year 2, or do I have to stay in my lane in that particular box on this particular in this particular policy? And it's definitely tricky. To answer your question, I think it's a collaborative effort around like what are the methods that we want to expose our children and pupils to, if I'm taking primary. And I think it needs some support from the maths lead, senior team. What does the maths curriculum look like? What are these methods? And then how does that fit into our school and our context? Is probably where I would, and collaborate with the teachers as well, so they have that knowledge of what the children, what methods are, kind of what children look at prior to them coming to their class. If they're in year 3, what have they done before, and where are they going, and what methods kind of cut across the whole primary school.
I agree, Emma, that it definitely has to be collaborative. I think that it's a really good question. I think there's probably something around the maths lead, or in secondary school, kind of the head of department, or whoever's leading that bit of curriculum, taking responsibility for sort of making sure it happens, because there's a risk that unless it's specified when it happens, which I think is probably kind of what the situations you've both sort of described and talking about, unless it's specified when it happens, pupils actually won't ever come across alternative methods for adding 99, subtracting 99. And so I think it probably is whoever's in charge of curriculum, is their responsibility to identify when they might first happen. But there needs to be that conversation about why it's then, and why that method is useful, and those kind of things. Otherwise, it'll either get kind of dismissed, and I think in terms of what you were talking about, Emma, I imagine it certainly in secondary I'd want it to be pretty flexible, in terms of I can't think of any for things that pupils know how to do. I can't think of many things where I'd want them to learn one way in year 7 and not another way, never ever another way until year 8. They might develop it. I think the other point actually is that and maybe linking back to earlier conversations, it's not just about when those methods are introduced, it's when they're returned to, an interleave. So I don't know if you're learning about, I'm trying to think of a good, perhaps you're learning about multiplying by 9 as multiplying by 10 and taking one lot off. Actually, that might be, if done carefully so you don't confuse pupils, a really good point to return to things about adding and subtracting 99, because it's sort of drawing attention to those similar structures. Because I think my own experience of teaching year 7 pupils is that you end up with like some pupils are really familiar with a wide range of mental methods and some are really not. And I don't think that's that they're not taught it. It's absolutely not that like primary school teachers are not teaching these things, but it might be that they're not coming back to them over time. Because like, and this happens in secondary as well, right? Like people forget stuff that we teach them at secondary, and then you get them in year 9. You're like, well, why haven't they learned that in year 7? No, they've just forgotten it because we didn't structure our curriculum well enough to make sure to try and make sure that didn't happen. But I think that coming back to is probably as important as the when to introduce. But maybe, and I'm not a primary specialist here, so I'm putting words in people's mouths, but like maybe that isn't thought about as much. Certainly it's not thought about as much at secondary, so I imagine it might be similar at primary.
I think we got distracted by the appendix in the national curriculum around about 2012, and the formal methods became the only methods. And so, you know, if you look at the work of Rittle-Johnson and Starr, you know, I think it's almost like every child deserves the opportunity to develop these really, really well, because it's the distinction between someone who is confident with mathematics, even just in a social setting, and those who are using the formal method to subtract 9,999 from 10,000. You know, I always use that as an example of, look how many opportunities there are to make a mistake here. Why not, you know, just like you say, subtract 1 and same difference kind of thing. Yeah, so I don't think there's a right answer. And I think, yeah, the collaboration, but the more teachers understand these, the more confidence they'll have to develop them as part of their practice. New teachers need to strike a balance between direct instruction and allowing pupils the space to explore and compare multiple methods independently.
It's all about the purpose that what you're doing it for. So, and I can think of certainly 2 really good reasons for like looking at multiple methods. Like one is like you get a bit more flexible and you can apply things in different places, which is something that this kind of paper backs up. Like if you know 2 ways of solving quadratic equations, you're probably going to be able to solve more quadratic equations than if you only know one way, and more efficiently and easily. Similarly, but then the other thing I think is like around exposing that kind of like structure of the mathematics, like why is this thing working, and like generalizing around it and building that kind of conceptual understanding. I think if you're just learning other methods for the sake of it, it's probably not that useful. There's a great book, it's probably more secondary focused than primary focused, by Jo Morgan, of like it's like a compendium of mathematical methods, where it just collates together all these like different methods she's found, and it's like 20 different ways of doing division or what have you that people have used kind of over the years. I definitely don't think there's no benefit to pupils going through and learning every single method in that book. Like to be clear, that's not what Jo Morgan's suggesting either. But if you're selecting them carefully so you understand like something broader about what's going on. So I guess even something which is kind of slightly useless. So generally when we multiply fractions, we multiply the numerators and multiply the denominators. We can, like, if we create a common denominator, you can still multiply fractions, and similarly divide fractions. It's just not very helpful. And like that might be a useful detour, but it sort of depends. Whereas the kind of different methods for like basic arithmetic, I don't know, like multiplying by something by 5, you can multiply by 10 and then half the answer, or all of those different kind of strategies, I think are much more useful in terms of that flexibility. So I think I've kind of meandered a bit there, but like I think, focusing on the purpose, like why are we trying to do it? Don't just like multiple methods are not there for the sake of it. I think they're a really great extension. Like one of my favorite ways of like pushing pupils is to say like, okay, find 3 ways of solving this problem. Because if you've got 3 ways of solving it, you probably understand it quite well. And that probably applies to like year 4 or 5 students doing some multiplication. And it certainly applies to like A-level students doing something on calculus. And if you can like, and even maths teachers, right? If you can get a maths teacher who can give you like 3 different ways of calculating the area of a square, they probably understand a lot of the underlying maths really, really well there. So yeah, the first part of that, like kind of methods, I think it's about what it's there for. I think like what your purpose is. I think in terms of striking a balance between direct instruction and exploration, I don't think this paper gives us like really firm conclusions about that. It's kind of a much broader question. But as I said earlier, I think it is important that the teacher gave some like direct instruction before the experiment. It seems to be direct, like fairly explicit instruction, like how to solve some equations. And I think that was pretty important scaffolding, as was having the pupils work in pairs. So I think what I'd maybe think about most is that like idea of the expertise reversal effect. So like while explicit instruction with lots of kind of small steps and practice and models is more effective than just like giving some problems to most novice learners, when learners develop greater expertise, the opposite is true. Actually, they benefit from, okay, here's some problems, have a go at them. But the key is that it's really domain specific. Like by novices, researchers don't mean like primary school pupils, and in the same way they don't mean like postgraduate students when they're talking about experts. Like I spent loads of my maths degree like being a novice in various different parts of maths that I was learning about. Even though I knew loads of other bits of maths, these kind of new bits, chaos theory or whatever, I didn't know anything about. So I had to start from like small bits and work up from that. And then similarly as a secondary school teacher, when I get pupils arriving in year 7, I can be pretty confident they'll be fairly novice at using algebra, and like benefit from lots of like broken down instructions and modeling and practice. But actually, most of them will probably be pretty expert at addition. So if I want to get them even better at addition, like even if it's like the column method or something, I should probably just give them some problems to solve. I shouldn't really waste my time with a lot of pupils in terms of like modeling how to do the column method, because probably they can do it. That will still be true as pupils progress through primary school, perhaps with things like times tables. And to go back to the paper, I think like that's why it's really important to know that pupils were taught about the algebra and how to solve equations before they compared the solutions. So they kind of had enough sort of cognitive space to like compare the one they've been taught and the new one, and make some kind of conclusions that they could apply later on. In a primary school context, like that might look like teaching pupils how to calculate perimeter of rectangles by kind of adding the sides in sequence, so like length plus width plus length plus width, getting them to like practice it, and then give them a worked out example where the like length and width have been doubled, and then added, and I asked them to explain whether like what's going on and is one better than the other and things like that. And this is just stuff that people do, right? Like all kind of primary school teachers, secondary school math teachers are doing this stuff, which is great. And I think that's really powerful about the research. Like the research tells us that's probably a good idea. It could have told us it was a bad idea. It could have told us that pupils learned less when they did that comparison because they got like sidetracked and confused. But actually it says that it seems to work, and it gives us some ideas about when it would be a good idea.
The study suggests that while structured comparison of like the solution methods enhances procedural flexibility and knowledge, it is most effective when supported by that explicit guidance rather than leaving pupils to discover everything on their own. And I feel like this thread of repeating ourselves, I'm going to repeat a word that I have also said a few times, which is balance. And in answer to your question, in one word, would be yes, balance is necessary. And I think I've kind of broken it down how to think about kind of like four things. One, that direct instruction provides a foundation. So when we think about comparing solution methods, it can require pupils to draw on prior knowledge. However, if this is lacking, they may struggle to compare methods meaningfully, or they might default to familiar but inefficient strategies. There's something for us to just bear in mind. The second thing is that exploration and comparison does develop that kind of flexible thinking. So once pupils have that foundation, allowing them to explore, and I come back to my early years, which is that play, let them explore those different methods, will help them and encourages that kind of procedural flexibility and then deeper conceptual understanding. And then comparing kind of multiple methods helps pupils then start to see these connections between strategies. And I suppose it's our job to make those connections explicit. And then it helps them to decide which is most efficient and then in different contexts. So, for example, when teaching subtraction, using the column method, let pupils explore kind of counting up on a number line, and then discuss which is kind of more efficient for different types of numbers. The third thing with kind of that over-reliance of direct instruction, can limit understanding. So if pupils are only kind of like taught like one, this is the correct way, they may struggle when they encounter, different problems that don't fit that approach. So pupils might develop procedural fluency, but then lack that conceptual understanding, making it harder for them to apply their knowledge to new contexts. And we know that transfer can be really tricky for some of our pupils. Whilst in kind of like some circumstances, that discovery can be effective, the research suggests that, for more novice learners, it is usually inefficient. And guidance can help pupils not waste time on inefficient strategies and can help reduce pupils developing misconceptions. And teachers could, provide structured comparison and select examples to share with pupils, as this seems to be more effective than any kind of unguided exploration. For example, instead of asking pupils to discover how to solve equations, for example, entirely on their own, as John's already mentioned, kind of providing those kind of two worked examples and then guiding them in comparing the steps. So one of the things was also to say was kind of gradually reducing that guidance can be really effective and support pupils to kind of have that guidance and then start reducing that as they become more expert. And where teachers can provide those clear explanations first and then gradually allow pupils to compare and explore and then evaluate methods, but with that kind of structured support.
What you guys have done is sort of give a really balanced, because I'm here setting up these ethereal antagonists who are espousing the ways of discovery only, but they probably don't really exist except in my mind. Really balanced, but also showing the link between the research that's happening and obviously thinking about conversations we've had about research that's been published recently, where people are starting to refine the connections between theories that have been posed over the last 10, 15, 20 years and how the things we do in the classroom might link to those, so things like the expertise, reversal effect. It's one of those things, I misinterpreted at the start. I assumed that when I first read about it, I assumed that, primary, we're never going to have any level of expertise because we're working at a very shallow level initially. And it may be that, whenever you're at A-level university, then you're developing expertise. Over time, speaking to people who are smarter than me, I realized that was a sort of erroneous line of thought. But there's a very good chance that someone listening may have just encountered it and be thinking along the same line. So I think showing those connections is really, really, really important. I suppose the last thing to touch on is whether or not it's necessary to adapt the comparison of different solution methods for younger students in a primary classroom. Now, obviously, we've spoken about early years a bit, and I think there are opportunities for informal conversations that just happen in early years, but with a view to primary, where some of these sort of solutions are going to be formalized and codified for pupils. What do you, Emma, what are your initial thoughts on this?
Great question. To answer the questions directly, I would say yes. And I suppose with primary age pupils who may not yet have the cognitive skills to independently compare methods in the same way as older pupils, that structured guidance and those concrete representations, I think, are really important. And I think I've mentioned some of these things kind of like throughout our conversation today, but kind of let's focus like specifically on like the primary age pupils and those settings for now. And many of your listeners and many of you will be kind of familiar with the idea that, you know, younger pupils benefit from working with those concrete manipulatives before progressing to the abstract kind of comparisons, which is a topic we've explored in the previous episode. And kind of, as I've mentioned earlier, kind of using those resources like Dean's blocks, fraction strips and counters allow pupils to physically explore different kind of solution strategies. And by engaging with these manipulatives, or another favourite of like drawing out their thinking, drawing out how they can solve these problems, they can then compare methods in a very kind of hands-on, concrete way before transitioning to any kind of written comparisons. And also what came to mind, Kieran, around this particular question was around the scaffolding and modelling. So younger pupils, you know, may struggle to identify those similarities and differences on their own during that comparison process. So I would suggest that teachers model this. We talked about being really explicit, modelling that first, and then scaffolding it for our younger pupils before they do it for themselves. And then also, you know, that thinking aloud is really important while comparing those, you know, the two methods could be a really great way for teachers to kind of explain those similarities and differences, and then asking those questions, you know, what is the same? What is different about these methods? Which method works best and why? And kind of getting them to kind of really unpick which method kind of works for them. Ultimately, it doesn't matter what their peers are doing, it's about this, what works for you. And I think being able to kind of model that side by side, I'm thinking kind of a split screen kind of you know, visual, can really help those conversations and that thinking aloud piece. So for example, you know, when teaching multiplication, kind of showing both the repeated addition method and then the grid method, and then discussing that, you know, with their peers as a class, to kind of work out what's best for this particular problem. And then one thing for primary, I think as well, is limiting the number of different methods that we compare at once. You know, too many options, I think I mentioned this before as well, but too many options can really overwhelm pupils, but particularly with our younger pupils. And you know, I've had pupils in year 6 often kind of, you know, they know how to do something, but they've just kind of gone into this cognitive overload and essentially maybe overwhelmed of all these different methods and strategies, and they can't select the one that is going to work for this particular problem. So I think, you know, let's really think about that when we're presenting these methods to our primary age pupils, and maybe just kind of starting with 2 contrasting methods and then gradually introducing more. And then the final thing was to kind of like encourage pupils to kind of justify their preferred method, both to, you know, an adult or to a peer. So after solving a problem using kind of 2 methods, asking them, well, which method, you know, do you prefer and why? And structuring that paired talk can help pupils then justify their preferred method and then deepen, you know, their procedural and then conceptual understanding. So I suppose in summary, I think, you know, the key is to simplify the comparison process, provide that concrete support, and then use those structured discussions to guide pupils. And as we know, as primary school teachers and leaders, kind of making learning concrete and explicit can help all pupils, but particularly those in primary settings, as this can build their flexibility in problem solving, while still developing like that really strong conceptual foundation.
Yeah, I'm definitely going to defer to your expertise on this. I got a couple of thoughts from kind of listening to you, and I've actually got a question for you as well. yes, definitely not just younger pupils that need help seeing the similarities and differences. I think that applies all the way through in secondary as well. So it's quite useful to see that kind of commonality. And then the other thing I was thinking about, like, absolutely agree around like getting them to justify their kind of reasoning, and that sort of sets the foundations for like even like going and doing proof later on, that like kind of helps them kind of become more mathematical in their like ways of thinking. But it's also perhaps like quite a nice tool for giving learners agency that I'd maybe not reflected upon that much before, like which one do you prefer best, but also sort of avoids that like, oh, here's a problem, everyone try and solve it. And now like, because then people get really attached to their own problem, their own way of solving it, whether it's efficient or not, or like feel that their methods are being critiqued and things like that. Whereas if you've got two different methods and you're comparing those two, it sort of takes them out of that, but they still get that chance to like express a preference, which is nice. That makes me think, I think it is another Rittle-Johnson paper where they studied whether it made a difference whether you like attributed the solutions to a pupil or not. So whether you said this was Emma's method and this was Kieran's method, or just method A and method B. And like I can't remember the outcome, so that is like a cliffhanger for anyone who wants to go and look and find out what that is. But it was a kind of fun little paper. But my question was, I wondered if there's something kind of counterintuitive about the sequencing with like problem solving and sort of guidance, like comparing solutions and kind of guidance. So like I'm interested in your thoughts on this, Emma, and Kieran as well. Like for very young children, sort of like early years and before, my guess is it's best to just like have them experiment and compare as part of play, and maybe like asking some questions like, oh, if I do it like this, is that the same? But then once they start working with more formal mathematics, does it quite flip quite hard in terms of like actually, I don't know, say they're exploring like the difference between grouping and share, understanding the difference in grouping and sharing, or like not something to do with number bonds. Actually, then they suddenly need loads more formal instruction before they start comparing different methods. I don't know. Is that a reasonable thing to think?
If I think about the early years, and there's obviously lots of focus on the early years, and in my opinion, quite rightly. And there's some brilliant articles and guidance that's come out recently about play, and that exploration for me is that play piece as well. And you're right, it's for early years them exploring with those concrete manipulatives, and then having an adult to ask those questions. So what if I just add one more, and physically, moving a little object over to that particular people at the time, and it's those questions and interactions with the adult, possibly another peer. But if you're modeling those questions, often those early years pupils will sometimes then imitate those questions with their peers. So if they're hearing, what if I did just do this, or I wonder what would happen if I just take one away, those kinds of things. And we're talking about weighing scales, and you've got cube, little objects again in the weighing scales, and they're kind of there's lots of different examples. But I think that exploration and those questions from adults or certain peers in the early years is really important. And then I was also thinking about the sequencing part of your question. It was really interesting. And I think there's definitely something to think about around the misconceptions that children may develop if that structure and that guidance isn't there. And so I think there is something around sequencing, kind of that the support that we give, and then the methods that we kind of offer them, to make sure that they don't develop like inefficient methods, I would say, and misconceptions that then can take time for teachers and pupils to then have to unpack, and kind of re-teach them efficient methods that are going to support their learning.
I think they're really, really good points. The only thing I would add is that I think a large part of it is to do with prior knowledge. And so, as we've been doing this conversation, I've been thinking about a particular year 3 class and my experience with them, because we spent a lot of time looking at alternatives to the formal algorithm early in year three. And I think and this sort of alludes to the research into manipulatives as well. Were those, you've had really rich experiences with mathematics when younger, and when a sort of gap between your developmental sort of trajectory and your actual competency in mathematics has when you've moved along that trajectory at sort of what the inverted commas average pace, then you can have fun with things like asking those questions. And kids will do that, when they're older too. Like my 10-year-old and my 7-year-old will have conversations where they really push the boundaries of the math they're exploring on the way to school. But they only do that because they've got a really good, secure knowledge of mathematics. And like, there are sometimes you're working with a 4-year-old or a 5-year-old, and you need to model the fact that you're going to move those counters because they're not yet ready to just look at a set and assign a value to it and stuff. And so that would be my thinking. I think depending on how much prior knowledge and how secure that prior knowledge is, that gives you greater freedom with your sequencing and with the way you approach it, which I think feeds into everything we've been talking about. Because thinking about that year 3 class, there were pupils who weren't ready for a comparison because they were struggling to get their head around why they would do it any other way. And so we would go to, like Daisy Christou's compartmentalization, where we break it down into, here are the parts, here's how they behave with each other, and only focus on understanding that part. Like, for instance, if part of the answer was making the bond to 100, and then utilizing that to make a more easy or some more easily navigable calculation, they didn't say, why am I doing this? And then we would focus our attention on how these bonds make this calculation a less taxing, because we do the count all with 3-digit numbers and think, well, actually, there must be an easier way to do this. So yeah, so I think it depends on where you are and where the pupils are. But I 100% with you, Emma, that that those are really good points you raised.
My takeaway from that was like, yeah, the play in that experimentation is super important early on, and the questions you ask. And also, and this is like recency bias from what I've been thinking about, but is expertise reversal effect again, even right the way down to younger pupils.
I mean, this is almost like your character arc, because I'm going to ask, like, what's next on the horizon for you guys? But is becoming a podcast host, now that you've asked the final question in this mini series, is that your arc in this? And what have you guys got in the fire? Anything that listeners would be interested in?
Quite happy with occasional guest appearances. What do I have on the horizon? I'm going to try, like, I've done a little bit of blog writing over the last 12 months. I'm going to try and do a little bit more of that. Currently kind of working on one around like what it means to know the maths that you're teaching before you teach it, and like how we can talk about that like in a way that is both kind of like sets ourselves like high kind of standards as teachers, but is also like really recognizes that it's a thing you do over time, and that no one, not even someone with a maths PhD, turns up on day one and knows all of everything they need to know about like the maths that they're teaching, particularly like misconceptions people have and things like that. And that kind of balance around like, yeah, being like teachers being a bit kind to themselves about it, but also still kind of striving to develop that knowledge.
Still laughing at the podcast. I really enjoyed this conversation, and John and I have talked about other podcasts that may be interested in discussing the expert edit or any other things around maths and other topics. But it's been really enjoyable to have the space, Kieran. So thank you, to talk about the expert edit that John and I put so much work and thought, care and attention into writing, and to then be able to have the space to then talk about the expert edit in 3 episodes, to really unpick the research and kind of share our views and opinions through a podcast kind of platform. I've really enjoyed, and I hope your listeners do as well. So first, thank you so much for the opportunity. But yes, watch this space. Maybe a podcast on the horizon. No idea. But yeah, I think for me, really interested at the moment. It's not math specific, but primary in all its parts is always a real pleasure to kind of get involved in and talk about. It's my passion, has been for my entire career. And supporting teachers and leaders to navigate that space, very much at the centre of the work that I do. I'm working on some SEND programs, products at the moment, and inclusion by design and all that inclusivity that we are no doubt all reading and very keen to explore more in our settings, is work that I'm currently doing. Also early years, if you've listened to all 3 episodes, is also very, very important to me, not only because of the connection to primary, but also because my son is in that space at the moment, so has a real kind of pull for me to explore more around that. I think it's reception ready guidance that's come out, and all the documentation around play, I think is fabulous, and anything that I can do to kind of support that more. And then I've been reading a lot about belonging, around kind of the relationship between belonging, behaviour, attendance and outcomes in schools. There's a recent article that's just come out by David Robson that's provided a really detailed analysis of this connection. So I want to kind of do a little bit more thinking around this piece around belonging. It's really insightful, that particular article, and David has in the article has cited lots of other really interesting kind of research and other studies about belonging and how it can help us address some of the challenges that the sector is facing at the moment. So yes, SEND, early years, belonging, primary.
Yeah, I think having had a little bit longer to think about it, I absolutely echo what Emma said. Like, it's the first time I've appeared. I don't know what the verbal word for appeared is, on a podcast, and it's been definitely was something I was a bit mildly apprehensive about, but you've made it so easy, and I've really enjoyed it. I think similar to Emma, I'm also kind of working on some kind of SEND things in terms of how we might work with real experts in kind of need and how we communicate the kind of most important bits of specialist knowledge to the sector, which is really exciting. And I don't know, lots of generally the things that I like reading about. I like maths education, and professional development, like coaching, mentoring, things like that. I've kind of quite a lot of work on mentoring things for ITT and ECT in the past, and I always think when we can get the more teachers we can support to be at that point where they view other people's development as part of their responsibility, and have some tools and some strategies for doing that, the better supported everyone in the professional field, and then the better pupils will do. So I think that kind of thing's always really powerful, really interesting. Thanks.
Fantastic. I mean, the thing is, I know that whatever you guys are up to, you'll be thinking really deeply about it. You'll be putting a lot of attention into it. So I think I'm very excited to see what comes over the next couple of months. And I'm, I wish this was my job, but I'm always really supportive of other people getting into podcasting, because I think the more people we have talking about the things that really matter in classrooms, the better. So I mean, you guys have got great chemistry. If you wanted to do it and I'll produce it for you, more than welcome to. I don't know what we had to think of a name though, because I'm all tapped out with the thinking deeply stuff. But I mean, I could, we maybe will release 3 hours, but you guys have easily given me 6 hours of recording time. I know that you've prepared for each episode because it's been a while since you read and wrote the actual edit itself. So it's massively appreciated. I've really enjoyed it. I think, certainly in the sort of connection with where people have been commenting and things, they've really, really found it useful. Certainly the numbers would suggest that they're revisiting it on a regular basis. So I think I'm going to try and do a big push to make sure it gets shared as widely as a set of 3. So all, this won't be the last time. But all that's left to do is say thank you very much for joining me. Thank you very much, Emma.
Thank you so much, Kieran. Thank you for having me.
Thank you, John.
Thanks, Kieran. It's been an absolute pleasure. Thank you.
And everyone at home, until next time, thanks for listening.